Hello, can you hear me? Yeah, nice. All right. Okay, so let's start. Thank you very much that you're here. I'm very happy. So I'm going to talk to you about managing your database in a CI/CD world. If you don't know me, I'm Ruben. I've worked here in FlixBus Charter for at least 2 years. I previously worked in a Venezuelan startup, also as a freelancer. And I'm a big fan of domain-driven design and DevOps culture. So let's begin. OK, so I know what you're thinking right now. Ruben, we're talking about CI/CD. Aren't you going to talk about tools like Jenkins or GitLab CI? What do you want to talk about MySQL or SQL database, a relational database? Does that make sense to mention it in a CI/CD way? Well, let me tell you something, guys. If you do it properly with the proper tools, this is something that can be done pretty easily, actually. But first, let's go through the basics. Who here use a CI/CD pipeline or use this concept of CI/CD? Yeah? Very nice. Yeah, mostly everyone has GitLab CI, right? Yeah, as you may know, continuous delivery is just the ability to let the user have the latest changes on the system, configuration change or everything, a new feature, in a very easy, in an automated way, in a safe way. And continuous integration is just the practice of integrating constantly what you're doing as a developer. OK, so how do we do continuous delivery and continuous integration in Charter? Well, we also have a CI/CD pipeline. Basically, what developers do whenever they want to push a new version of the application, well, it push it to master with a particular branch, a particular version. We use a versioning control system like it. And then we trigger a CI/CD pipeline. What it does is it builds first the application. It makes some checks. It makes some unit tests there. It makes some integration tests. Afterwards, it packages the whole system, the whole application into a Docker image. Then we load it into the Docker registry, and we automatically deploy. So we have two areas, basically, in Charter. We have an integration area and a production area. In the integration area, we do some tests there. Some of them are manually, and some of them are automated, like the E2E test, and these are done automatically. And the production area, whenever we know that everything is working fine in the integration, we deploy to production with a click on a button, and then it automatically is deployed there. OK, so whenever you have a CI/CD pipeline, it's very simple to set up this in a stateless application, like a Java system, an API, like a REST API, or something like that. It's very simple to do. But when you're working with a database, or when you're working with state, it's a little bit more tricky. Why is that? Well, we could find some problems in the integration area, some problems in the production one. And what I'm going to do is I'm going to tell you about the problems that we have encountered in the past and how we fixed it. OK, so coming up with the integration area. So the questions here in integration, well, in integration we have every developer has a particular branch, and they're working with their system, with their version of the system. The system needs a database. And the question here is, how can we maintain a synchronization between the different databases in each branch with the production one? And also, how can we allow the developers to have this database into their own computer? And how can we do this in a fast way? Well, what we have decided here in Charter is that we don't want to have those problems. You don't have these issues when you have any data. So what we do here is we avoid statefulness. We avoid to have this synchronization between the data and the production one. Because if you make a dump, at the same moment you finish your dump, there's going to be much more data there. So it's just an illusion what you have there when you make a dump. It's just an illusion of a particular state of this moment of the database. So I want to avoid that. What we do is we wait until the system is ready, the database is ready, and we populate afterwards the database. And this is very easy to use in Kubernetes. or a orchestrator system like Docker Swarm or something like that. And it's very easy to use if you are a newcomer, a new developer. Normally, you will have to wait some hours until you download the database. Even if you have like a slow connection or something like that, you have to download 40 gigabytes, something like that. Now we only have to download 400 megabytes. That's pretty good. Yeah, so the question here now is, how do we populate the database? OK, so what we did here in Charter is we created our own project, and we call it the Charter Seeder. What we wanted to do here is we wanted to kill two birds with one stone. First, we wanted to populate the database, of course, and we also wanted to test the API. Basically, we just use the same API we're using for the backend, for our REST API, to populate the database. And also, we make some assertion there to see that everything is working fine in the iteration area, and also in the local environment. We don't have 60 gigabytes there in the Charter Seeder. We just have some useful test cases. Everyone can contribute with data. So we started first, me, Diane, David, some testers. We check there, but everyone actually can just clone the project, check the data there. If they want to put some more, they can just do it. Is this something like very hard to do, this project? Well, basically, no. I mean, how did we do it? Well, basically, it's just a bash script. It's automated through GitLab. The formats that we use is just JSON collection, the same that are used in Postman. So basically, if you are using Postman, you can actually check the collections that we have there. You can make assertion with Postman, put it in the repository, push it, and then new data is going to come to each branch. Each version of the application will have this new data. For the bash script, we use a Newman, which basically is like Postman, but written in JavaScript. This is like very easy. It's just like you just make like core requests. So pretty nice. So we have talked about the integration area, the problems that could arise there, how we solved them. But now it's time to talk about production. Production is tricky because you're dealing with data there, and people are using the database there. OK, so the first and most important problem that could arise in production is how to make changes in the database. OK, so the database schema changes, so the schema migrations. OK, so if you're working with a relational database, you have to do it at least once in your life. Because the business is always changing. The domain is changing. You are discovering new things. And there are new requirements coming. And if you want to change the architecture or change something in the system, and you're changing the classes, you will have also to change the database schema. Also, data in production is important, right? If you do something wrong there, the data could be corrupted. It's very easy to roll back a stateless application, a Java system, if you're using Kubernetes. But it's not so easy when we're talking about the database. You have to lose at least some minutes. At the moment you're rolling back, you're also losing data because people are coming in and putting some new data there. So updating the roles and everything. And this could lead to fear of changes. One story I love to to say is when inside the thing, people were discussing about a particular migration that started talking about, like, I hate doing migration. Yeah, of course. If you don't do it properly, you start hating migration. You start hating the changes. OK. Inside our team, in Charter, we have a lot of changes there. We are constantly changing the schema of the database. Because we want to go through, towards a microservice architecture. We want to have our own self-contained system. For that, we want to decouple the data. We are constantly changing that. Also, the business is always researching the best way of manage the business. Also, there are new requirements, and we want to like model the domain as best as possible with our classes, and of course, the database schema. We also had some changes in the cloud provider changes. So we started first like an internal in an internal network charter, and we had to move to the AWS, to the cloud. And for that, we didn't want to have any downtime at all. All right, so these changes were pretty hard for us. How do we deal with this like critical schema migrations? Well, at the past, we just made the changes before working hours. We gathered together in Slack, 2 a.m., 4 a.m. in the morning. We run the migration. We hoped for the best. And this of course, it's not the proper way to go. I could tell you guys about a story about a particular migration that we started. I think me and Dimitri, we were together, 4 a.m. in the morning. We run the migrations, and that didn't work out. It was supposed to last for 45 minutes. 4 a.m., 45 minutes, you're good to go. I mean, 9 a.m., you come here in the office, and yeah, everything's going to be fine, right? But this migration in particular lasts until 4 p.m. We had some problems with the database there. So obviously, I mean, that caused some issues, right? We were really tired that day. Really tired. And the business people weren't happy at all. They were asking us, why are you doing this kind of stuff at working hours? Well, we started at 4 a.m. in the morning. So of course, for us was like, okay, so maybe we need to research a way of making it better. Maybe there's a technical solution that can help us with making these schema changes. But first, we wanted to check why does this happen in the first place? Okay, so in MySQL, depending on the engine you're using, there are different algorithms for the alter tables, the changes you're doing in the database. So there's one called in place, which tries to make the changes without making any copy. I mean, tries to make the changes there concurrently into the same table you're doing. Another one called copy, which copies the database, the table, makes the changes there and then it tries to switch it over. Normally this works pretty well. I mean, the concurrency there in MySQL is pretty nice, but there are some edge cases where there are some blocks into the updates, the writes, or even the reads. I mean, you had to read it. You had to know the documentation and know what you're doing before making this, because otherwise there could be locks into the tables. I mean, users could be not allowed to write into the table or even read. And this could have like a high load because there's like a big line waiting to enter the table, and they basically cannot do it. Yeah, of course, ultimately you are the one who are responsible to read the docs and make the changes there, yeah. But still, we research a little bit, and we could find a way of making all the schemas migrations on working hours. How do we do this? Well, basically, we follow a same pattern, which is we try to mimic the way MySQL does the changes in the copy algorithm. We try to copy the table, make the changes there, and we switch. And there are different solutions that they follow the same pattern, but they do it in a different way. We consider two. From the guys from Percona, these guys, they do like a really good toolkit for MySQL. There is a tool called PT Online Schema Change. From the guys for GitHub, there's one tool called Ghost. And they do the same thing in a different way. So let me tell you a little bit about this. So the Percona one, the PT Online Schema Change, is based in triggers. So what it does is, yeah, the same pattern. It tries to create an empty table. It modifies the table. It copies the data step by step, and then switch it over. It makes a rename table, an atomic one, so no one realizes that you're making some critical migrations inside the table. And you're probably asking me, yeah, okay, but what happens if there are new changes, maybe some updates there, some inserts, even some deletes into that particular table? Well, what happens is any modification on the table, it replicates it towards the new one with triggers. It installs some triggers there in the old table, and any changes is replicated to the new one. So it's basically like a master to slave replication, but only within tables. So it's really fun. The only problem with this approach is you cannot use trigger, basically. So if you are using triggers inside your tables, you cannot use Percona, the PT online schema change. The other approach from the guys for GitHub is called a triggerless approach. It uses the same pattern. It's no magic here. It creates an empty table, it modifies the table, and it copies the data very slowly. But the difference that we have here is that instead of using triggers, it's a triggerless approach, right? It reads the oh, okay, nice. We need a master to save replication. And between this replication, what is happening here, it reads the logs on the server. And it replicates from the old table to the new one, just by reading the logs. So this is like, if you have like row-based binary replication, you read one by one the lines, and basically it replicates the data. And this one has like several advantages, because depending on how much your logs last inside the servers, you can actually pause the migration for as long as your logs live. So for example, if your logs live for 1 day, you can actually, you start a replication at 5 p.m., you pause, you go to sleep, you go back to the office, and start over again. And it's going to work fine, because it's just reading the logs. There's no magic here. Yeah. The only problem that this one has is that it doesn't allow you to have foreign keys constrained into the MySQL database. So if you have this, it cannot work. Yeah. So basically, okay. So you select your solution. It depends on the thing at the end of the day. If you want to use foreign keys, or if you don't mind about that, yeah. Or if you want to use triggers, or if you don't mind, you select the solution. Then you have to automate it. Basically, we consider two options. One of them is like decoupling completely the database from the application. Have your own repository for your database and everything there, all the migrations there, and make a CI/CD pipeline. So every time you want to push a new version of the database, you do it. You trigger a CI/CD pipeline, and this does automatically. It goes to production and makes the changes there. Or you can actually just integrate the solution with the release, which is basically just when you're making a release, you integrate the solution there with your own application, and the changes are triggered towards the database in production. This will work fine. At the end of the day, it just depends on the team requirements. So basically, we decided to use the second one, integrates the solution with the release, and when we do a release, we basically trigger a migration there. Okay, so where do we go from here? Well, what we'd like you to do is basically just try yourself if you are working with a relational database. There's lots of documentation out there about continuous integration, continuous delivery, even these online schema changes there. The solutions that I told you about are basically open source, so you can actually use them. Basically, you can experiment with them on your production environment, and it will work fine. And afterwards, just automate it, and let's see how it goes. So that's basically from my side. So any questions?